my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we discussed about function with argument and with return. In today's video, we will discuss the remaining types of user-defined function. So in that, we will see function with argument and no return. Means it will take the input but it will not return anything. One more, function without argument, no inputs, but it will return something. So these are the two different types of user-defined function that what we are going to discuss in today's video. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Function with argument and no return. So what is this type of function? Means it is taking input but it is not returning anything. It means to say it is going to print the output in the subprogram itself. That's it. The second type, it is function without argument and with return. Means it is not taking input itself. Then how it is going to return? So here is a big question here. So here comes one more concept of local variable and global variable that we'll discuss in this type of function. So how we can compute something without giving input. So it is going to access global variable. So what is this global variable? We will see. The first one we will discuss function with argument and no return, and then we'll come back to this. So here is the complete program. So a very simple program. So here we are seeing multiplication of two numbers and the function name is multiply. Return type, look at here. It is a program to illustrate function with argument and no return. So it should have argument but no return type. So how do we indicate that it is not returning any value? It is represented by void. Void is called as empty data type. Void is called as empty data type. Okay. Now, so in the declaration part, the function name is multiply. Return type is void. It is taking two arguments. Both are of integer type. Let me start with the main function. Two variables we have declared, int a comma b. So as soon as the compiler encounters a variable declaration statement, it is going to allocate the memory for that. Then I get the message. So what will be my message in the output screen? So I get a message, enter two values. So as soon as the user reads that message, the user has to input two values. So I am going to enter 2 and 3. Okay. So it is scanned and stored in the address of A and B. So it is 2 and 3. Fine. Then I say multiplication of two numbers. I'll get a message like this. Multiplication of two numbers. Colon. Then that message will be printed. Then the next line is function call. So as soon as the compiler encounters this function call statement, what it has to do? It has to check with the declaration. So whether this function is declared? Yes, multiply is declared. How many arguments? See, again we need to check with the arguments aspects. The compiler is going to check with the aspects of the argument, number of arguments, type of arguments and order of arguments. How many arguments we have? 2. Yes, it is done. Type of arguments, both are of integer type. Yes. Order, first one is also integer, second one is also integer. So here, as soon as the function call is invoked by the compiler, it is checked with the declaration part. And am I assigning this to any variable here? No, I am not assigning to any variable. It means to say it is not returning any value. Okay, so here what happens, if it is not returning any value, the return type will be void. The return type will be void, indicating that it is empty data type. So declaration gets matched, and the control will be to definition part. The control will be to definition. Here the control comes to definition part. Here I am receiving these values with the formal arguments x and y. So here a, b are called as actual arguments which are carrying the actual values through the variable names a and b, where a I am having 2 and b I am having 3. Right. I'm receiving that with the formal arguments. X and Y are called as formal arguments, receiving that with X and Y. X is receiving 2 and Y is receiving 3. So here let me write the memory block. X and Y. X is getting the value 2 and Y is getting the value 3. Get inside the function, execute the single statement. I say straight away result equal to percentage D, compute and print X into Y. 2 into 3. So it is 6. I'm going to get the result. You can just have a new line here. You can just say new line. It will come to the next line. Result equal to print an integer, that is X into Y. Then again control us back to the place where the function was called, and the next line is this closing bracket of the main function. The program ends. Fine. So this is what with function with argument and no return. Here one more point I need to specify. See, here I am using different variable names. It is not that you have to use different variable names. You can use A and B itself, no issues. Let me write A and B here itself. A and B are local to this main function, but A and B are local to this sub-function. But when I say A and B, they are different. New memory will be allocated here once again. So for example, here the memory address of A is 200 and this is 300. Let's assume. Okay. And here I created the same variables once again as formal arguments to receive the values formally. So here A and B are different variables. They are created newly. So here let it be the address say 400 and this is 500. Different locations. So if you have the same variable name, no issues. But sometimes what happens, if some confusion arises with the actual arguments and formal arguments, it's better to have different variable names. If you have the same variable names also, they are treated differently because they are created newly with a different memory location. Okay. If I say AB, again AB is created freshly with different memory. So if I say AB here, it is in 200 and 300. If I see AB here, it is 400 and 500. But having same variable name, sometimes it leads to some confusion. It's better to have different variable names. So I can just say X or any other variable names according to your wish. X and Y. So here what happens? X and Y with new memory I am going to get. That's it. Compute that. But whatever variable names you are using here as formal arguments, you can use that in the declaration part also. No, not a problem if you have mentioned or not a problem. If you are mentioning the formal argument in the declaration part also, make sure you are using the same name here also as well as in the definition part also. See here I have to say X into Y. So through which variable names you have received, you have to use the same thing in the definition part also. And one more thing to tell here, I have straight away computed to save the memory. You can also use one more memory here. I say int result. Okay. Then you can say result equal to X into Y. This also. Then I can simply say instead of X into Y, you can say result. That's it. You can do that also. So this is function with argument and no return. After printing the result in the subprogram itself, there is nothing to do in the main program, but the control will be back to main program. If it is not returning any value, it means to say it is not carrying any value. That's it. But the control will be back to the place where the function was called. Okay. So the control will be back to the place without values. Then close the or end the main program. This is with the function with argument and no return. So here is the program to discuss about the function without argument and with return. Without argument means it is not taking any input, but it is going to return something. So here comes the concept of something called as local variables and global variables. So we have two types here. Local variables and global variables. The name itself is self-explanatory. Local variables are the variables which are local to the block where it has been declared. The scope of that variable will be only within the block where it has been declared. Outside the block, the scope of that variable will not be there. We cannot access it. But global variable is the one that is accessible throughout the program. So when we have this user defined function concept, we say throughout the program means we have main program and we have subprogram. This is what the complete program is. Main program and subprogram. Coming to this global variable, it is the variable, or they are the variables which can be accessed throughout the program. Means it can be accessed in the main program as well as in the subprogram. So where to declare this? It has to be declared globally, means outside the main function, so that it can be accessed in the main function as well as in the sub function. So here comes the global variable declaration. We have also initialized the value. You can initialize it either in the subprogram as well as in the main program also. Let me show you both the methods. Initially, we have initialized the values in the declaration line itself. So here what happens? So here this is what global variables. So we have two global variables. As soon as the compiler encounters the global declaration here, it is going to allocate the memory for that. A, B, the values 10 and 20 are initialized. Then we have the function declaration. The function name is multiply. Return type is integer. No arguments. We have no arguments. You can also write void also. Not an issue. You can simply leave it blank. And one more thing, you should always remember, when the statement is having the brackets like this, the parenthesis, it indicates that it's a function. That you should remember. Then starting with the main function, execution starts from the main function. We have a local variable here. So here we have the local variable, and this local variable is accessible only within this block where it has been declared. Inside this main function, again we can have many subblocks also. Again, if I declare a local variable, that variable can be accessed only within this block. It will not be accessed outside this, like this. Okay. So res is a local variable, so memory allocation will be done for res. Then I'll make a function call. This is declaration, this is call, and this is definition. Okay. Multiply function I'll call, but no inputs I'm sending. I'm not sending any input. I'm simply calling multiply. So as soon as the compiler encounters the variable that is function call, without any variables that I'm not passing any inputs to that, first it is going to check with declaration. Yes, multiply function is declared. Any arguments? No arguments. Is it returning some value? See, the complete function call is assigned to a variable res, which is of integer type, so the return will be int. Yes, everything gets matched. Control the definition part, multiply. I say return a into b. If you want, you can have a local variable, compute, and then return that variable. I don't want to waste the memory. I simply compute and then return. Return a into b. So what is the value for a, b? It is accessing the global value. What is a? It is 10. What is b? It is 20. So it is 10 into 20. It is 200. Return to the place where the function was called. Okay. So it is 10 into 20. Return to the place where the function was called. Res is going to get 200. So then control is back to this place. Next statement, you have two statements, three statements, 1, 2, 3. Multiplication of two numbers. So you get the message, multiplication of two numbers. Let me write it completely. Two numbers equal to percentage d, print the value of res. It is 200, get ch, main program ends. This is what function without any arguments and return. It is not taking any input, but it is returning some value. So here I am not passing any input, but some computation is done with the help of global values. So it is returning that result. Well, you can simply declare it like this also. See, what I can do here is, I can simply declare without initialization, A comma B. And here you can do the initialization. After clear screen, you can do the initialization. A equal to 10, some values, whatever you want. B equal to 20, or else you can do it here also. A equal to 10, B equal to 20. Because A, B are declared globally. It can be accessed throughout the program, both in the main program as well as in the subprogram. This is what function without argument but with a return. So let us see the actual execution of both the programs.
So here is the program, which is the program to illustrate the usage of function with argument. Look at here in the declaration, with argument but no return, so it is void. This is function declaration and this is function call. So we are simply calling the function but we are not taking any values. So here itself I am printing the result. So let us see the execution. This is multiplication of two numbers. We have seen the dry run. Now we will see the actual execution. Control F9. Let's enter two values, 2 and 3. See, multiplication of two numbers, result equal to 6. Multiplication of two numbers is the message that what I got from the main function. Result equal to 6 is the message that what I got from the sub function. Look at here. So this message, then function call, control to here, I am printing the result. Let us see one more program, that is function, which is not taking any argument but it will return something. That is no argument with return. So here comes the concept of global variable declaration. We have declared two variables, int a equal to 10 and b equal to 20. See, look at this, the function declaration. We have the function declaration with no arguments but it is returning a value. So in the main function, what we are doing, we are calling the function result equal to multiply. That's it. We are not passing any value, but it has to return something. So control will be to this function definition. Here I say return a into b. So which a value and b value it is going to take? It is going to take this global value. So it is 10 into 20. So let us see what happens now. Control F9. Yes. Simply get the result, multiplication of two numbers, that is equal to 200. You can do one more changes here. What we can do here is, we can simply declare as global variable and we can initialize these values in subprogram also. So what we'll do here, we'll say a equal to 10, b equal to 20. In the main function we can initialize. Let us see, let us save the program, the changes we need to save and then we need to execute. Look at here. Yes, we got the answer, multiplication of two numbers equal to 200. The same thing you can also do it in subprogram also. Let me comment that. I'll initialize the values in the subprogram, in subfunction. I say a equal to 10, b equal to 20. Save the changes, control F9. See, the same thing. So we can initialize the values of the global variables in the subprogram as well as in the main program, or else you can do it in the declaration line itself. Hope you have understood with these two kinds of function, that is function without argument but a return and with argument and no return. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.